Okay, so we've talked about the inverse sine and the inverse cosine functions. We now want to talk about the inverse tangent function. So here's our tangent function. And we see we get all these kind of little disjoint pieces. We need to find a piece that we need to restrict the domain so it pass the horizontal line test. So we're going to take this part right here. Okay, so we're going to let our domain, or the restricted domain, is from negative pi over 2 to pi over 2. And we see that we get the full range. This goes up this way, this goes down, from negative infinity to infinity. Okay, so here's a copy of it, just restricted. So inverse tangent, the domain is going to be from negative infinity to infinity. You can put any value in there. But the range is from negative pi over 2 to pi over 2. So if you're thinking about the unit circle, this is the right-hand side of the unit circle. Okay, and we see a graph of tangent inverse, and the process is very similar to what we've done with inverse sine and inverse cosine. So you're going to set theta equal to tangent inverse of x. So if we want tangent inverse of 1, we're going to say theta equals tangent inverse of 1. Then we're going to rewrite it as tangent of theta equals 1. And we're going to use the unit circle between negative pi over 2 and pi over 2. So remember, that's the right-hand side, where any angles in the fourth quadrant, you're going to write them as the negative angle, to find the value of theta that satisfies tangent of theta equals x. So we're going to pull up our unit circle. Okay. Now, we're looking on the right-hand side, and remember, tangent is y over x. So you want to say, where is y over x equal to 1? And 1, you have to have the same thing over itself. So that would be, if we take square root of 2 over 2 over square root of 2 over 2, we would have 1. So tangent of pi over 4 is 1, so, or 45 degrees. Okay, then we want to know what is tangent inverse of negative square root of 3. So we'd say theta equals tangent inverse of negative square root of 3. And so then we would say, okay, tangent of theta equals negative square root of 3. And let's look at our unit circle. Now, negatives, the only place where we get negatives are down here in the fourth quadrant if we're looking at the right-hand side. And we want to know where is the y over x square root of 3. And let's look at 300 degrees here, which we would write as a negative 60, because we want to write it as the negative angle. But if we look here at this one, if we took negative square root of 3 over 2 over 1/2, these 2's would cancel out, and we would have negative square root of 3. So this happens at 300 degrees. But since we're down in the fourth quadrant, we need to write it as how many degrees did you go negative to get there? And that would be negative 60 degrees. Okay, next we want tangent inverse of 0. So we'd say theta equals tangent inverse of 0. So tangent of theta equals 0. So where is the y over x equal to 0? So here at 0, 1, we get 0 over 1. So this was going to be theta equals 0 degrees. And then D here, we want to know where is tangent inverse of square root of 3. What is tangent inverse of square root of 3 over 3? So we'd say theta equals tangent inverse of square root of 3 over 3. So we'd say tangent of theta equals square root of 3 over 3. Now, since this is positive, we're going to look in the upper quadrant, the first quadrant. Okay, and we need to know where is y over x square root of 3 over 3. Now, if we do 60 degrees, we're just going to get square root of 3 because the 2's will cancel out. But look what happens if we take 30 degrees here, which would be 1/2. Oops. So 30 degrees there, if we took the y over the x, it would be 1/2 over square root of 3 over 2, which the 2's would cancel out, and you would get 1 over square root of 3. Now, if you rationalize that, you get square root of 3 over 3. So that's exactly what we're looking at. So theta would be 30 degrees. Now, for just a second here, I want to talk a little bit about something that these notes didn't cover. What if you see one of the other inverse functions, cosecant inverse or cotangent inverse or secant inverse? And let's just for a minute get some white space. So let's say you come across something and it is one of the other functions, cosecant, secant, or cotangent, and you want to find cosecant inverse of, let's say, 2. Okay? Now, cosecant, remember, is the reciprocal of sine. So the first thing we would say, okay, theta equals cosecant inverse of 2, which means we want to know where is cosecant of theta equal to 2. And then we would turn this into a sine. So if cosecant of theta is equal to 2, that means sine of theta is equal to 1/2, is equal to the reciprocal. So then you would find that and you would say, okay, this would happen when sine is 30 degrees. So theta equals 30 degrees. Okay, so whenever you see cosecant inverse, this would be the same thing as sine inverse of 1/2. Okay, so to kind of write that out generally, cosecant inverse of x is equal to sine inverse of 1 over x. Secant inverse of x is equal to cosine inverse of 1 over x. And cotangent inverse of x is equal to tangent inverse of 1 over x. So we really talked about the 3 main ones, and that's because you can find the other ones using the reciprocal properties.